Okay, we're going to talk about Unit 5. Unit 5 is talking about linear relations, and most linear relations deal with patterns. So we have to be able to figure out how a pattern is created, and then we're going to create an equation from a pattern. So the first thing we see here, our outcome is to describe world problems and solve our world problems with patterns, okay, with linear equations and verify solutions. So it says, can you predict the number in the pattern 5, 9, 13, 17, what will come next? 21, how come? It's going up by 4s, good. So when you're finding a pattern, you're usually finding what they're actually doing to a digit. So we can find all kinds of different patterns. So here the common difference is 4. They're going up by 4. Okay, that's what we call the common difference. So if we had, I can give you another possible one. So let's say if we have one that was going 4, 8, 12, what's this guy doing? He's going up by 4 again. So it doesn't always have to start with the digit 1. This guy started with the digit 5, this guy started with the digit 4. Okay? You could have them going up by any absolute number. They could be going up by a fractional amount. Okay? So we're going to take a look at writing an equation from a table of values. So this is what's in your actual other set of notes right here, okay, in the little set of notes I gave you. So there are steps to creating an equation from a table of values. So whenever we're given a table of values, it's either going to be given to us as a vertical list up and down, or as a horizontal list going left to right. So this is what we call a vertical list up and down. The first on the left is X. He's always X. The guy on the right is always Y. It will always go alphabetical. Okay? Always, always. Now what they've done here is they've used letters according to the actual situation. So they've used letters for problem solving. Could we change them back to X and Y? Absolutely. Okay? So if you like the X better, you'd say plots is X. And if you like boards being Y, you'd say boards is Y instead of B. Okay? That's the only difference they're doing. They're changing the letter to match the problem. So, what we've got to do is we've got to figure out for each number of these plots, because what we're doing here is, our example says we've got a landscaper. And he's going to be designing herb garden plots. So, it says he's going to be designing and creating them with boards. So for one plot, how many boards did he need to use there to make one? 4 boards. You need to enclose a space with 4 boards. So one plot was 4 boards. Okay? Well, if I made 0 plots, did I use any boards? No. So we would have started at 0, 0. All right. Now, let's look at 2 plots. So I'm just going to raise this up a moment so I can show you in the outline. So here's my first 4 that you can see in red. Okay, you can see that little red there that I outlined? Now, I'm just going to use a different color here. So I need to add 1, 2, 3 more boards in order to create another plot, because I can use this board right there. Okay, so now I need to count how many boards are on this guy. I've got 4 plus 3 more. 7. Okay. So we have 7 for the 2 plots. So now if I know that these right here, that's 7 boards, because 2 of them is 7. What am I going to add to make my next one? You're going to add 3 more. Okay? So it's 7 and 3. 10. So now we can see a pattern in our table. I've got from 4 to 7. How did I get from 4 to 7? I added how much? 3. How did I get from 7 to 10? Added 3. Well, what do you think I have to do next time? Add 3. So what's 10 plus 3? 13. And what's 13 plus 3 more? 16. Good. So these ones with 5 plots, we should have 16 boards here if we were actually counting the number of sticks and boards. Okay? Now, using this information, we're going to do exactly what it says in our steps here. Okay, so we're going to create an equation to match the information. So, to create an equation, it says you find the pattern in the Y list. So the pattern means, what is it going up by or what is it going down by? Okay? So if you're not sure what that means, that's what you're going to write down. The pattern means what is it increasing or decreasing by? So what is it increasing by? So what amount? What amount is it increasing by? Or what amount is it decreasing by? That's your pattern. So we found it was 3. Then we got to look on the left-hand side, because it says take the number from the Y pattern, and it says we got to divide by the pattern number in the other column. So I know the pattern here is going up by 3. What's the pattern on the left? It's only going up by 1. So it's only going up by 1 here. So what we do is we do this. We say our pattern is 3 divided by 1. It's always the Y divided by X. So Y divided by X. Always, always. Now it's not the Y digits divided by the X digits. It's the Y pattern, what it's going up by, divided by the X pattern, what it's adding by. Okay? So we find our pattern. Now we're at step 2. It says take the number from step 1 and put this number in front of the variable X. So that means this pattern number right here, 3, is going to go in front of the X letter. So I'm going to have something looking like this. Let me move it up. We're going to have Y equals 3X, because it'd be 3 over 1. And 3 over 1 has to sit in front of the X. Okay? Now it says, step 3, I want you to write this little hint. It's called test point. Okay, so step 3 is all about taking a test point. And what a test point means is you take a coordinate from the table of values. So you're going to take it like this. You're going to take either the 1 and the 4, or the 2 and the 7, or the 3 and the 10. They have to be a matching pair. Pay attention, please, back there. They have to be a matching pair. Okay, we have an X number and a Y number. I'm going to use the 1 and the 4. Okay, so that's my test point. So, what I do now is, okay, so I'm trying to find out what my Y number is going to be. I have to times this guy by the X number. Well, my test point is at 1 and 4. That's my X, that's my Y. Okay, we're getting that from the table of values. Now I'm going to put those numbers where the X and the Y are. Okay, so the Y number is a 4, the X number is a 1. Okay, so now what we do is we do bedmass. I need to make sure that the left side is going to end up with the same answer on the right side. So I want the left side to equal the right side. So this is how we create the equation. I say to you, 3 times 1 is how big? 3. What do I have to add or subtract to it to get 4? I have to add 1. So we know it's not a subtract, it's a plus 1. So now what we do, after we've checked one test point, we have to check a second test point to make sure this pattern will work. So my equation is then, I put X and Y back for X and Y. So I have Y equals 3 times the X plus 1. This is the equation I got from doing a test point. Okay? Is everybody following so far? We'll do lots of these, don't worry. We're going to do lots of them. We're going to take this and we're going to check the next test point. So the next test point was 2 and 7. So now we've got to put the 2 and the 7 where the X and the Y are. And then we see if the pattern works. Will my left side equal my right side? So our next one we're trying is 2 and 7. So I'm putting a 7 where X is, or sorry, a 7 where the Y is. This guy becomes 7, because my next point is 2 and 7. 2 is the X, Y is the 7. Okay, you should be writing this down. Now, I take 3 times the X number, which is a 2, and then plus 1. And I want to see if the right side's equal to the left side. So let's do bed mass now. Which part am I going to do first on the bed mass? Am I going to take 2 plus 1? I need to multiply first, because they're sitting side by side. Multiplying goes before adding. So 3 times 2 is 6 plus 1, 7. So you get 7 equals 7. So when your left side equals the right side, you know that this is the true equation. You did it correctly. That is the true equation. Okay? So that's what we figured out. Okay. So another example, they're showing us again some plots, but they want the perimeter of these blocks. They're saying they're blocks. So if I want now the number of blocks compared to perimeter, that's something completely different. Okay? So when we were doing the last question, we had to include the ones in the middle because those were part of our garden plots for boards. But for this question, we're only doing the perimeter, which means the outside. So we're not actually counting the inside squares, or sorry, the inside separations. So if we take a look at this guy, I've got my first one has a perimeter of 4. So I would say first one has a perimeter of 4. Okay? So we need to make a table of values. You don't have a table written on yours, so you need to create this table of values in your corner. Okay? So create it in the corner somewheres. Middle of your page, on page 119. So for block 1, we have a perimeter of 4. Well, what is our perimeter of the next guy? Well, let's count. 1, 2, 3, 4, 5, 6. So our second one has 6. What do you think the third one has? 8. Third one has 8. What do you think the fourth one has? 10. Good. They're showing you these perimeters right here. Okay? Now, let's create the equation according to what we see in the table of values. So what is the pattern on the right-hand side? Goes up by 2. What's the pattern on the left? Goes up by 1. Good. Now, in order to find the number that goes in front of the variable, remember, this guy's x and this guy's y. So in order to find out what the number is, it's always the right side divided by the left side. So 2 divided by 1, which is 2. So we're going to get y equals 2 times x. Now we say plus or minus something equals our y number. This is the part that we always have to try to fill in so that we can create the equation. So we would always set up our equations generically like this. We would find our pattern. You put the pattern in front of x. Now we have to find out what we have to add or subtract to get to the next number. So let's pick a test point. Which one would you like to use for a test point? We can use any of them. 2 and 6? Okay. So we're going to use these guys for our pattern. So I have a 6 for my y, equaling 2 times my 2. And now I have to say plus or subtract something. So what's 2 times 2? 4. So we're going to get 6 equals 4 plus something. What do I have to add to 4 to get 6? 2. 2. Good. So now I know the number here is a plus 2. I can take away that subtract sign. There's no subtract here. It's an actual plussing. So that tells me in my equation way up here, I don't need a subtract sign. What I need is a plussing 2. Okay? So now I get my full equation right here. But remember, we got to pick one more test point to make sure he works. So which test point do you want to check next? 4 and 10? All right, let's check 4 and 10. So now again, we're putting in the numbers for y and for x. So y is this number right here, x is that guy. So we have 10 equals 2 times the x number, and then plus 2 more. We want to see if the left side is equal to the right side. So, what's 2 times 4? 8. Plus 2 more? 10. So 10 equals 10. So the left side does equal the right side. So that means we found a true equation. Okay? So our equation is correct. We found it true. Okay? That's how we know. Now there's other questions down here. There's a couple of them. And the first one says, the 10th set of blocks has a perimeter of what? Well, they're saying they want the number for 10. What would the perimeter be if you've got 10 blocks? So they have to put a 10 where x is. So let's use our equation. I'll just put it over here. Y equals 2 times 10 plus 2. So the number for x always goes where the x is, and that's 10. So how big is 2 times 10? 20 plus 2 more? 22. So this is a coordinate point, you guys. They told us the x number is 10. We got a y number of 22. That means on the graph, that is at 10, 22. That's what that means. Okay? Everything is on a map. These are locations. Okay? So 10, 22. Whenever we make a coordinate point, it's always x, y. Always alphabetically. X first, then y. Okay? Alright, so now we have our general equation. We have our general equation, which we found, our 2x plus 2. They used n and p for perimeter. So they have 2n instead of 2x, plusing 2 gives us our perimeter. Okay? That's what we figured out for this one. Now, here's a special note. It says, is it possible for a sequence of numbers to have a difference that is negative, which means they're going down or subtracting numbers? Is that possible? Yeah, you bet it's possible. So that means I could have a number that starts at 100, and I can start subtracting 5 every time. So I can go 100, 95, 90, 85, 80, 75, 70, and all I'm doing is subtracting 5 every time. So yes, you can have a common difference, absolutely. So the answer to this guy is yes, you can. Okay, yes, we can have a possibility of that. Okay? All right, couple more examples. We're going to turn the page in the workbook. All right, this one we have a horizontal table. So far, we've been dealing with tables of values that are straight up and down. That's called a vertical, okay, straight up and down. Now, this one's called a horizontal table of values. Boys, you need to focus please up here, or I'll have to separate you. So right here, this is called a horizontal table because it's writing the numbers left to right. So now, the top number will always be the x. So this guy is x, this guy is y. Okay, always, always. It will be alphabetical. The top will always be x, and the bottom will always be y. All right. Now we got to, again, who do we find the pattern with? We found it on the y guy, the guy on the right. So when it's written horizontally, we find the pattern on the bottom. So what's this guy going up by? 2. So this guy's increasing by 2. What is the n top row going up by? 1. So this guy's going up by 1. So remember, we have to divide them. It's always the y divided by the x. So the pattern is 2 over 1. It's always y over x. Okay, that's our pattern. So now we got to create the equation. So we're going to say 2 times our x plus or subtract a number is equal to the y. So we're always starting with a generic statement. Okay? So whatever the pattern is goes here. So there's our pattern. The pattern goes in front of the x variable always. Elijah, pay attention please. So the pattern's always in front of the x. Now we pick our test point. And you can pick any test point you want. I'm just going to randomly choose one in the middle. So I'm going to check 2 and 8. So that means the x is 2, and I need to make an 8 in the y. That's what's happening. So I'm going to have 2 times 2 plusing something to give me an 8. Well, what's 2 times 2? 4. How do I get from 4 to 8 on the number line? Add 4. Good. So we know it's not a subtract. We know it's an adding 4. So now we're going to check a test point, one more, to make sure it works. I'm just going to check the one on the end, 4 and 12. So 2 times 4 plus 4. Do I get 12? Well, let's see. What's 2 times 4? 8. Does 8 plus 4 give me 12? Yes, 8 plus 4 gives me 12. So that's how we know the left side equals the right side. So because that's true, this is the correct equation. So it's going to be 2x plus 4. Okay? Is the equation. 2x plus 4 equals y. Okay? All right. Now they've used different letters instead of x and y. So if I wanted to write it with the other letters instead of x and y, all you're going to do, who did they use for x instead? N. Who did they use for y? T. So I could have this guy saying 2 times n plus 4 equals t. So you could rewrite it like that if you like. Okay? Now, if they ask us about a number, what if they say you have a t number of 12? Oh, we already know that one. How about we have a t number of 22? Okay, t number of 22. Can we find the n? Yes. So, this is what we're going to do. I'm going to erase this blue right now, and I'm going to show you how to find that. So, if they say to us we have 2n plus 4 equals our t number. So if the t number I tell you is 22, we're just doing a linear equation solving for n, which is unit 4, what we just did. So 2n plus 4 equals 22. So now we're back to solving for x. What is the first step I would do to solve that? Yeah, we've got to subtract 4. So we're going to take the 4 to the right. So we need to make a 0 pair. So we're going to subtract the 4. So we're going to get 2n's is equal to how big? 18. Now what do I do? Divide by the 2 to get rid of it. So divide by the 2. How big is n? 9. Good. So that tells me my coordinate point. That tells me if I have a number up here that's 9, I'm going to get a 22 for an answer. That's what that's telling me. Okay? Let's look at the very bottom one here on example 3. All right. Example 3 says, find the 100th term in this pattern. So you've got 7, 4, 1, -2. What is it doing every time? It's decreasing by 3. We could also say subtracting 3. So it's subtracting 3 every time. So it says, therefore, we could create our equation. So, if we want to call, they're saying y is t and b or n is x again. So they're using t and n again, okay? Now I'm just going to go back to x and y. I think sometimes that's a little bit easier for you. So, if I want to make a table of values, I would have x and y. And if you don't like the x and y, they're using t for y and they're using n for x. Okay? Okay, Elijah and Embry, you need to pay attention because honestly, you're just pissing around back there. Leave the brushes alone, no touchy-touchy. Okay, so we have these numbers here, right? So we had first term was 7, second term was 4, Third term was a 1. Fourth term was a -2. Okay, there's the table of values. We found it just from what they were saying. What is this number? How did I get those numbers? What did I do? How did I get the numbers on the left? They didn't just magically appear. I got them from this list. Who's the first number? 7. So first number, 7. 4 is the second number, so 2, second number, 4. That's all it is. So right here on the end, that tells me what number I was looking at. First number, second number, third number, fourth number. Okay, that's what that means. On the right-hand side, that's the actual digit it is. So here, we're subtracting 3 the whole time. That's what we're doing. And this guy, what are they going up by? These guys are adding 1. So we've got a subtract 3 over a positive 1. This becomes our pattern. So that number is always written in front of the n or the x. So this is now going to be -3n. Plus or subtract a number, which they call b here, equals my y number, which is t. Y or t you could call it if you want to call it t. So here's our generic equation. We have to figure out what they're adding or subtracting to get to that next number. That's what our job is right now. So let's take a look. We got to pick a test point. What test point would you like to use first? 1 and 7, the first numbers? All right, let's use those numbers right there. So the first number, n, is going to go for a 1. Y is going to be a 7. So I want a 7 here and a 1 where n is. That's what I'm doing. All right. So now I put my -3 beside him, and I'm timesing them, and I have to add or subtract a number to get 7. So what's -3 times 1? -3. So I have -3 plus something gives me 7. What do I have to add to a -3? I'm way over there on the negative line. Then I have to jump over to +7. You have to add 10. Okay, we're going to add 10, and that's going to get us to +7. So that means up here, we can now cross off the subtract part. It's not subtracting it all, it's adding 10 is our missing number there. Okay, so now the equation becomes this. Y equals -3x plus 10. Okay, so it'd be like x and y versus the t in the end. Okay, so that's how they created the equation. Here they're saying, how do you find the 100th term? Well, that means the 100th number. How do you find that answer? Well, if that's the 100th number, remember we use x or n for the number, so we would say -3 times 100 plus 10. So what's a -3 times 100? -300. Plusing 10, -290, and that's what they're showing you there. Okay, so we get -290 when we put the 100 in where x is. Okay, and that's what they're showing us there. Okay, do we have any questions so far on these couple examples? It's going to take practice, okay? We'll do a few more together, don't worry. Got one last example here, example 4. So this one is a written question. It's a word problem. Whenever we're given word problems, we have to think of who gets the variable. There's always going to be a base number and then a number with the variable, always. And that's something I want you to write a little note for. So, linear equations have a base number and a number with a variable. Always, always. So we're going to find something that's got a base number that doesn't have a variable, and then we're going to have a number with a variable. Okay? That's what all linear equations we're going to be dealing with. So we're going to look at the very first one. So it says, Rent-A-Wreck rents cars for $30 a day plus 20 cents for every kilometer they drive. So your base cost is how much you have to rent or how much you have to pay per day. Okay? That's your base cost. Then you have to drive and you get charged per kilometer. Wherever it says the word per, if they use per twice, you have to see which number is going to get the variable. If they use per once, the guy gets the variable. Okay? So the first number, it's usually always a big number. That's always your base cost. So we're going to circle, this is our base cost. Okay? That's our base cost. Then we've got 20 cents per kilometer. Do we know how much we're going to drive, how far every day?
No.
No. So that's why that's the number with the variable, because you don't know how many kilometers you're going to drive. So our equation is going to look like this. Cost equals $30 plus 20 cents per day. So I'm going to use D for days. And how would I write 20 cents using dollars? 0.20, good. So I have 0.20, and again you can use K for kilometers, D for distance, okay, or D for days, okay, but I'm going to use actually K for kilometers here, okay. What they've done, they've used N for kilometers, okay, which is fine, N for number of kilometers. So, B says, what is the cost if you drive 120 kilometers in one day? What would you have to pay that rental company? So they used the equation, and they had to put the 20 kilometers, or sorry, the 120 kilometers where the letter K was. So that's why you see where they have their N, they put the 120. And all it is bed mass now. So now you're just going to take your 0.20 times the kilometers, and then add the $30 left over. You're going to get 24 plus 30, which is $54. Okay, so that's what the cost is for the first one, 54. Now, if you look at C, it says they charged you this much, $57.40. How far did you drive? So if they gave you a Y number, they're asking you to solve for N. You're literally doing a solve for X question. That's why we had to do the other lesson first. Or sorry, the other unit first, unit 4. We had to learn how to solve for X first so that we can use those strategies here. So, if we know that that's our answer, we're solving for N. So we get 5470 equals 0.20 X or N if you want. I use kilometers plus 30. We're back to a normal linear equation. So now we take 30 to the left. How do I take 30 to the left? Subtract 30. Good. And subtract 30. So now I'm going to get $24.70 equals 0.20 kilometers. I want to get this variable by itself. What do I have to do now? It's sitting side by side timesing. So how do you get rid of it? Divide it out. You have to do the opposite. Divide out 0.20, and then he's gone, and you get your hidden positive 1 in front of your variable. So this side has to divide out by 0.20. And when you do, you're going to get a big number, 137. So kilometers are 137. So you drove 137 kilometers because you had to pay $54.70. Okay? All right. I'm going to throw another one up here, and I want you guys to practice this question with me, okay? So you should have extra room on, just even on the side of the front here, on one of these, on the very front of your notes, or even in your workbook, you might have room on the side. We're going to do a table of values. We're going to create an equation. So, example 1. Here's our first table of values. We're going to call this guy X and this guy Y. And we're going to have 7, 6, 5, 4, 3. And then we're going to have Well, let's go with 60, 65, 70, 75, 80. Ooh, that's a crazy one. All right. So, again, in order to create the equation, we need to find the pattern right here and right here. So, what's the right-hand side adding or subtracting every time? Adding 5 every time. Good. What's the left-hand side doing? They're subtracting 1 every time. So we have to write our pattern becomes y over x. Well, that's 5 over negative 1. What does that become? 5 over negative 1. Negative 5. Okay, it becomes negative 5. So now I know my pattern number. The pattern number always sits in front of the variable on the left in the column. Okay? It's always in front of the x variable. If you had a table of values going this way, left and right, it would sit in front of the x on top, the top row. Okay? So far we've got this. We've got negative 5 times my x plus or subtract a number equals our y. So this is our generic statement that we say the minute we find our pattern. So our pattern gets written in front of the variable. Okay? So the pattern is written in front of the variable. Then we draw a box. We don't know yet if we have to add numbers or subtract numbers. So we always start with plus minus something, a blank or a box, to equal the y number. Okay? Now we're going to take a test point from our table of values. Which test point would you like to work with?
5 and 70.
5 and 70. All right, we're going to deal with this one. So I rewrite everything. And so now I'm putting in 5 for my x and 70 for my y. Okay? So I'm putting these two numbers right here for this number and this number. That's where they went. Okay? Now we do bedmass. So we have to multiply these two numbers. What do I get with negative 5 times 5? Good. Negative 25. Now, remember, this is a number line. You're way over on the negative side, negative 25. And you have to get all the way to positive 70. So how am I going to find out what that missing number you have to add is? What do you think? I'll show you a trick. If you're not sure what number to put there, you always take the guy on the right-hand side and subtract that guy. Now, how do you subtract a negative? I want to subtract a negative 25. What happens with these two? They switch to adding. So what's 70 and 25? 95. So I want everybody on their calculator to try this. Right now, I want you to type in negative 25 plus 95. Make sure you get 70. Okay? You should get 70 if you type those in. You should get 70. So because this happened, we know this number now is a plus 95, not a subtract. We can get rid of the subtract sign. It's a plus 95. So now we need to do one more test point to make sure this works. So, negative 5 times a number plus 95 we found equals the y number. So, we need to pick one more test point. Which test point would you like?
3 and 80.
3 and 80. Alright, we're going for 3 and 80. 3 for x, and the right hand side has to equal 80. Alright. What's negative 5 times 3? Negative 15. If I add 95, it's negative 15. How big do I get? Positive 80. Okay, so we get the left side equals the right side. This is super important, you guys, that you prove this. Because that means your equation is true. It's a correct equation. If the left side didn't equal the right side, that means your equation's wrong and you'd have to try again. Okay, you'd have to try and find a new pattern. Okay, any questions on this? This concludes lesson 1, creating patterns from tables of values.